This is instruction for Signor Volta and shows how to build a battery. Two beaker setup. You can see I've already have my beakers in place. And there's this list of reactants or materials. I'm going to start with this zinc sulfate and the zinc bar. Almost always you'll need both a salt and a metal. And the metal and salt will match. So if this is a bar of zinc metal, ZN metal, that will be an electrode, and it can sit in a solution of zinc sulfate. I'm using gray because zinc is a gray metal. The ions are colorless, so this is a reasonable representation of what I hope looks like a colorless solution and a zinc bar, an electrode. The half reaction that zinc undergoes is Zn solid turning into Zn2 plus by releasing two electrons, and the potential for that is plus 0.76 volts, V for volts. And this is a good thing because it will help make the battery work. It's positive voltage. I have a copper bar. So you know copper is a nice reddish metal. So here's a second electrode. And this is a piece of copper metal. Once again, the solution will match the metal, but copper sulfate is a nice blue color, so I will represent the copper ions with this nice blue color. Sulfate ions are colorless, so if I were doing it really well, I would draw them gray. There's a solution of copper sulfate with the copper electrode. The half reaction on this side is a reduction. Copper ions, Cu plus 2, aqueous, will accept or grab electrons to become copper solid, copper metal. That also has a favorable potential. So together, this gray half reaction and this blue half reaction will make a nice battery. Historically, this is called a Daniell cell, named after the person who invented it. Only two things left on the materials list: some wire and a salt bridge. The wire will be used to make a connection between the two electrodes. I'm going to add here a light bulb. If you don't put anything useful between the two electrodes, you won't notice that electricity is flowing. You may get some heat, but it's not very interesting unless you have a device in between. The last piece of equipment is called a salt bridge. That is a hollow tube, often made of glass, sometimes plastic, and it will be filled with ions that allow conductivity. So it's not filled with air. It has to be filled with aqueous solution. I'll just put Na+, and how about sodium sulfate is a good choice. Na+, SO4 2. These are aqueous ions in the salt bridge, and they can migrate. You should remember that ions that are mobile conduct electricity. Therefore, the salt bridge allows electrical conductivity through this central region here. I'll go ahead and add the potential here. Overall potential 1.10 volts. That's a battery. If it is a battery, electrons must flow. And I'm hoping you can see the zinc is the electron donor, whereas the copper ion is the electron acceptor. So we have a wolf on the right. Here's the wolf, the electron acceptor. We have a goat on the left. That's the donor. So electrons will flow from the goat through the light bulb and on to the wolf. So it is an electron transfer through the wire. The copper ion will never directly touch the zinc metal, but that's the reaction. Copper ion oxidizes zinc metal. The last two words I'll add are vocabulary terms. There are two electrodes. The site of oxidation is the anode, that is this zinc, the zinc metal, the zinc bar. The site of reduction is the copper bar, the cathode. So these are just vocabulary terms used to describe the two electrodes that always exist in an electrochemical cell, like a battery.